this week, the session has a special character because the two talks will be given by our candidates for a academic upgrade. So the topics have been chosen so that they can show what they can, how they can contribute to the program of ÚFAL. So let me welcome the two candidates. First of them is young Hajič Jr., who will talk about reading and predicting music history. So you know you have, well, 45 minutes, which includes discussion as well. So thank you very much.
Thank you for the introduction. Thank you everyone for coming. And in the coming 45 minutes, including discussion, I will do my best to show what I'm working on, what my research topics are, and I hope that by the end you will be convinced that it makes sense to have me on the team, so to speak. So I have chosen a somewhat provocative title for the talk, which is Predicting Music History, which of course doesn't make too much sense, but only at first sight. On second sight, music history means musical sources. Parchment, paper, books, free leaves. There are like archives with thousands of these lying around. Magazines, digital media, etc., etc. And written sources are the key, the one key that we have to actually understanding our own European musical heritage. Plenty of these are available in the digital domain, millions of pages, but most of them are only available as images, which really helps when you're trying to perform this music, but doesn't really too much help when you're trying to do computational research on top of that. So the first line of predicting music history that I do is taking images such as these and translating them in ways that enable practicing music, performing music, engaging with this music by people, such as myself. And reading existing sources, because we are at Matfis, of course, this means reading them automatically, is the field called Optical Music Recognition. I'm pretty sure it's rather intuitively obvious what optical music recognition does. It's OCR for sheet music. You input an image and you output something that you can edit in the same way that OCR works for text. You input an image, you can then do stuff to it in Microsoft Word. But OMR is hard. It's not like OCR, and it's its own field because music notation is pretty complicated. It's more complicated than existing scripts, even including Hangul, Chinese scripts, Arabic scripts, whatever. Because, first of all, text is usually one sequence, notwithstanding some weird Siberian writing systems from Yukagiri people. That took a while to find. Music can be encoding multiple sequences at once. These sequences interact with each other. They appear, they disappear. This is stuff that doesn't usually happen when you're reading text. Also, the shapes that you see on the page can get pretty much arbitrarily complex. There are rules for building them up, but you can apply these rules recursively. So there isn't really a finite vocabulary of glyphs. And most importantly, the information about musical content, which is what we're trying to get to, right? We're trying to figure out like which key should you press to play that note. This information is spread out across notation. So in order to figure out what key that note is, you have to look at the beginning of the whole line to figure out how to interpret those things are called staff lines. how to interpret these in terms of which key am I supposed to be pressing. And you also have to look at things that may have happened in the meantime, like this modification. You're supposed to press the black key next to the white one. This also applies for that note over there. And this cannot be easily decomposed into a tree structure, which would also be relatively easy to linearize, right? You have things like measures, which are these segments that have a stable number of beats, etc. If you've ever had any kind of music theory or music lessons, you know what these are. But and they look like a natural element that works as a sort of a boundary for performing OMR. But nope, you also have elements of notation that span measure boundaries. And any decomposition you might try to find, you will find notation elements that break the assumption that you can decompose it nicely. Also, from an object detection perspective, it's a relatively difficult problem with many tiny objects on one page, even though this is not as much of a problem today for object detection algorithms. So, because it's hard, we do it. And we do it in the hard setting, which is musical manuscripts with music notation of arbitrary complexity. You can get around some of these issues by restricting yourself to just working with, for instance, flute music. There is just one line. Flutes don't really play multiple pitches at once, notwithstanding some special cases. But we want this to work on arbitrary complexity of music notation, including piano. And we want this to work with musical manuscripts that are in our memory institutions, such as the Moravian State Library, with whom we are working on this as part of a NACI project that I have the fortune and misfortune to be the PI of. The objective here, the first step, is retrieval. So retrieval is quite tolerant to some amount of mistakes, which is why we chose it as a reasonable objective for this first attempt to really process complex musical manuscripts. This is the kind of data that we're working with. These are actual images from our data set, except for this one. This we'll get to later. Well, you cannot do this without a data set. So this is the one thing we're doing. At this point, we have roughly 1,000 symbols and 700 relationships between symbols on each page. Our target for 2024 is 100 pages. I hoped I would be able to say today that we have 100 pages complete, but 6 of them are still waiting for reviews. The previous state of the art, which I also did here, had 140 pages, but they were smaller and they were also just black and white. So it was like a research problem. It was very nice to have for defending a dissertation, but now we're moving on to actual realistic settings where this can be applied for predicting, the content of music historical documents. And the ground truth for this, the way we're annotating it, is the music notation graph, which is a representation that allows us to treat the issue of OMR, of recognizing music notation, with all its nasty properties, as just 2 machine learnable steps. So we detect the objects. This is a well understood problem in computer vision. It just needs the data. Currently, we have results on our 76 pages or 94 pages by now, where for the staff layout, the F-score is about 0.97. This is an easy problem in terms of object detection. These objects are large, they're well-defined, but I'm still happy that it works. For node heads, which are those fundamental elements that tell you play a note, and then you're decoding the properties of the node head to figure out which note you should play. These we can get with an F-score of about 0.98. This is very, very recent. Fortunately, Wojciech was able to do this like last week, so I have numbers. On other objects, unfortunately, those are numbers from yesterday, and they are much worse. But at least we are roughly where we were with the previous black and white images. So that's the first step, object detection. We'll need some tuning, but actually for retrieval purposes, already just getting the staffs and the node head positions is good enough because you can build melodic contours. You don't have to care about which exact key this is. You just encode the sequence as, okay, this is line number 3, this is staff space number 4, this is line number 3 again, and this is already a query, like an indexable thing. the library people are putting this in their Solr. So the object detection, that's the first step. The second step is to get the edges of the graph, right? Then we can extract the musical semantics. The edges we just treat as a binary classification problem. You can train this with pairs of objects that are connected as positive examples, and then within some distance threshold, you choose about 10 times as many pairs of objects which are not connected, and this works as your training data for this. It's inspired by the arc parser thing from NLP, where this is the way that you can say, okay, there should be a syntactic edge here. We call those are the red edges, we call them syntax even. And this, we know from experiments in 2019 that it should work, but so far Wojciech hasn't been able to get this step running. So this is work in the very close future. And the semantics inference part of this is already implemented. Previously, it was able to get 4 out of 5 pitches, and unfortunately, only about 2.5 out of 5 note durations, right? We'll see how this works here. So, okay, we have OMR as a machine learnable problem, but of course, it's not for free. So this ground truth is really expensive. It's currently averages out at 11 hours of annotator time per page, which is completely unbearable. We are working on this and trying with better annotator tools, but maybe this goes down to 5, which is still way too much. So the answer might be synthetic data. We want to take an existing machine-readable representation of music, which in practice probably means the music XML format, which is an interchange format for music notation. And we want to be able to render it so that it looks like one of those difficult to read manuscripts from the library. And for this, we have Jiří Majer and his Meshcima system under the supervision of Pavel Pecina, but he's still working for me on the project. And currently what we have looks like this, or this for a different writer, or this. Again, work in progress, but I believe together with some post-processing methods to make the render scores more realistic, this can probably significantly alleviate our training data issue. And we have full control over the positioning of the elements, and we can deform the results in various ways. It's just a matter of investing the man hours. It's not a technical problem. Okay, so maybe we can get past the training data being really expensive. But we still have this as a two-step pipeline, which in the age of end-to-end learning is maybe not so great. There isn't really a good joint loss function for this. I've looked at inferring scene graphs directly from images, and people have formulated this in many ways since I think 2017, but none of the results are really convincing yet. So the problem in OMR, which differs from scene graph reconstruction, which is usually relatively simple stuff like man catching ball, is that we need 4 to 10 correct decisions about edges or non-edges. Well, we always need at least 10 decisions about non-edges in the vicinity of a node head. But this is how many we need to make the correct decision about the node's semantics. This is just duration. For pitch, we need some 4 or 6 more edges usually. So even with a 99% accuracy, this still translates to quite a few mistakes. This is an inherent problem of this approach. But we are in the age of end-to-end recognition. So we tried doing OMR also for this difficult, hard to linearize, multi-sequence music notation with recurrent networks. And the key enabling thing is that Jiří Majer created a way to linearize this music XML representation in a way that can be de-linearized back into the XML, even if this sequence contains some errors. So it's somewhat robust to the model doing something wrong. You still get a valid music XML file out of it. This was a lot of work. Jiří spent his youth on it. Unfortunately, this turned out to be work well spent because thanks to the deep learning prowess of Milan Straka, we defeated transformers on an easy piano music dataset. And because that was too easy, we created a harder dataset, which we now say is the state of the art in piano music recognition. This is what it looks like in terms of errors. These are samples with the median error rates. So some stuffs are much, much, much worse. But this is what you can expect to get in about 50% of cases. It will be this or better. And this ties back to the synthetic data part, because what we now have is a sequential representation for music XML files. We have a way to render music XML files as musical manuscripts. So maybe if someone trained a language model on the LMX representation, we could get not only endless variations of what one score looks like, we could get an endless number of scores. They will be pretty crappy music, but they will be valid music scores that we can train on. Okay, so that was the optical music recognition part. That was predicting the music history that we can check is predicted correctly. Well, it's kind of the boring part, right? What about reading sources that don't exist? Or rather, reading sources that we lost. We think were there, but aren't anymore. And I'm working on this for mapping the evolution of Gregorian chant. And now we get into computational musicology. And this is supported by the Genome of Melody project, which ended recently. It was supported by the John Templeton Foundation. I still need to write the final paper for that. And there is this ongoing digital analysis of chant transmission, where I lead the chant analytics group, which fortunately provides some stipends for our students to also work on this. So what's Gregorian chant? Who has never heard of Gregorian chant? Who has never heard Gregorian chant? Oh, wow. Too bad. Okay, well, most people have heard it. So to reiterate some basic points, it's vocal monody. So it's just a melody that's sung on a Latin text. It's liturgical. The performance itself is a ritual. What this implies, modern concert performances notwithstanding, is that if this act itself is sacred, you're doing your best to keep it conserved, because if you do it wrong, you're doing it wrong. It's like you're supposed to stick to the prescribed sacred melody and text and the way the text is underlaid on that melody. What sort of complicates this endeavor is that historically, chant was primarily sung from memory. For many hundreds of years, there was no exact notation. And when there was one, still the books were rare, and you were still expected to remember most of the repertoire. The book was there for learning and for double checking. And this is what the books looked like. So this is a page from a chant book, from a source from this is roughly the 13th century, I think. It's from a German-speaking area, which, never mind. So like I said, this kind of book was there to enforce the conservation of this tradition. And besides the music, I'm pretty sure you can kind of tell which parts are the music. There is also this red part, like this one, which says in Vigiliam Assumptionis Beate Maria Virginis, which tells you when this is supposed to be sung. Specifically, it's the evening before August 15th. And we know this because we know about this thing called the liturgical year. You may have heard of terms such as Advent or Lent or Easter or Christmas. So the church has not just these major periods of time and feasts. The church for every day has a prescription. This is what you're supposed to pray. And a part of this prescription is what you're supposed to sing. And this is a principle for how chant books are organized. So there is no Control F in the year 1200. So what you do instead is, because you know what the next day will be and what you will need on the next day, you just leave a bookmark. You come to the book the next day, you open it where you left the bookmark, read up on what you're supposed to sing, and then just move the bookmark for the next day, right? So this is how chant sources are organized. And because the liturgical year is standard for the entire Latin Church, we can take sources and compare them. We can look at different versions of the same chant in different sources. And some of these are from Switzerland. This one is from Belgium. These are Czech. These are German. You can tell from the first letter. And you see that it's the same text. Usually it's for Christmas, but some sources have this for Advent. So there's some slight variation in how repertoire is assigned. And what chant scholars have been doing for the past 20 or 30 years is putting these catalogs into a database. And you have this thing called Cantus ID, which shows you, okay, these are different versions of the same chant. And if you look at the melodies, which are supposed to be the same, by now you can probably tell that they aren't. So practically no two chant sources have exactly the same melody for one chant. But it should have, right? By definition, it should be the same. And the research questions that I work on are connected to this variability in a place where we technically shouldn't find it. And there are questions such as, is this variation systematic or is it just errors? And are there even like regional dialects in melody, so to speak? And the way to study this is, I think, because chant melodies are strings. Fortunately, those are just melodies, not the complicated piano music stuff. And it turns out that the alphabet of possible elements of the melody has roughly the same size as the amino acid alphabet. And they are shorter, usually. So the computational tools that, for instance, David Hoxha knows very well, can be relatively directly applied to this material. Of course, just computing something over a bunch of strings is what you always can do. The question is, does this have any power to actually model the historical evolution of Gregorian chant? And then we can, only then can we use this to actually measure chant melodic diversity. So, are phylogenetics applicable to chant melody? Well, in theory, we have to look at the history of chant. So phylogenetics means, or applying evolution, the evolutionary theory implies that you believe that there is some sort of common ancestor, that every two items that you're comparing have a common ancestor somewhere, and that the majority of transmission is taking place vertically, so along the edges, that there isn't really too much interaction like between, I don't know, birds and ants, right? That what's happening on the bird clade doesn't really talk about what's happening on to the evolution of ants, or at least not too much. So does the history of Gregorian chant and what we know about its transmission fall under these assumptions, at least well enough? Well, we have, so first of all, we have data for this part. That's where we have staff notation manuscripts, right? Actual exact pitch notation comes around the year 1050. And then after 1600, we start getting print editions and the rules of the game, so to speak, change. So it doesn't really make too much sense to study later chant with the same methods. The manuscripts look like this. I mean, you just have the one melody, but you know exactly what pitches this is. So this is how we get the data, right? The sequences of letters that we can then feed into the methods. And the interesting part is this early chant history, which fortunately does involve a root of sorts. So this thing in around 800 AD, 750 to 850, is a period when the Carolingian Empire was founded, when Charles the Great did his "I am the emperor now" thing. A part of imposing a unified identity on this previously disparate bunch of kingdoms that maybe weren't particularly happy about being part of an empire now. As part of this, he imposed a unified liturgy, and Gregorian chant was his chosen, the selected liturgy that would become standardized across his empire. And we know from musicology that there was a certain transmission pathway where monks were coming from Rome down here to Metz up here, and there they would revise what they were doing in Rome for the needs of the Frankish Empire and write new liturgical books, and these would be distributed across the empire and copied and redistributed, etc. So we have this root event. This is important for the applicability of phylogenetics. And also, this is the time where we have interesting opportunities, because we might have some music notation, but we don't really have exact pitches in this. We know some rough melodic contours, but it's hard to reconstruct. I mean, there is this one source which, for those notation signs, actually provides the letters. Incidentally, they're the same letters that we use in the data. It's called the Volpiano encoding, and I think it's the oldest standard for digital humanities, because by now it's 1,000 years old. And this is very rare. Mostly you get this, where you don't really have an exact idea, and people use different symbols in different regions. And reading this is a challenge. It's an open question in chant scholarship. So between these two events, which we can call standardization, in 1600 is the print-based standardization. In 800, that was the Carolingian imposition of Gregorian chant. We have this long period, 800 years of differentiation. And the transmission mechanisms that were at play at that time are memorization. Like I said, oral tradition, you don't have exact notation, you have to remember it. And you have to learn by listening to someone else. You do this in an institutional setting mostly. Chant is sung by professionals, by schoolboys in education who are already treated as young professionals, and by the clerical class who are full-time. Basically, some of the monks in this period are almost full-time chant singers. And we have these two modes of transmission, the memorization and manuscript copying, which is also a very vertical process, right? Here's a manuscript, copy it. Okay, now here's a manuscript. I need a new manuscript, copy this one, right? These are also transmission chains, which are mostly vertical. And this runs over a long time and a large area. And we have the theory of cultural evolution, which aims to formalize from these intuitions about mechanisms of how culture evolved into computational models. And without going into too much detail, chant fits very well into the category of what's called oblique transmission. And it fits, these mechanisms of transmission fit with the idea that, again, phylogenies might be useful, because you have a low within population heterogeneity. So within one monastery or within one parish, you have one book that you're currently using. But you have high heterogeneity between populations. They have a different book, right? But they're consistently using that one. And the opportunities for horizontal transmission, so for like somebody coming over to Poland from France and saying, you're singing it wrong, here, let me fix it for you. Those were rare. Like, you wouldn't touch the books usually. There are events in which you would, if you had significant reasons to change something, which usually came with big changes in repertoire or some reforms or something, but usually you wouldn't touch the book. They were really expensive. Okay, so in theory, I hope that you understand, even if I did not go into the cultural evolution detail, that phylogenetics might be applicable at least to the manuscripts well enough. What about in practice? Do the methods actually predict things that are plausible? So for this, I fortunately had Gustavo Ballen as a colleague on the Genome of Melody project, who is an actual bioinformatician and a specialist in phylogenetics. And thanks to him, we were able to build a pipeline that actually gives us music historical predictions that we can validate. So we align melodies, we treat each source as an organism, basically. We treat its melodies as its genome. Again, the protein, I'm sorry to actual bioinformaticians in the audience, but this is a very rough analogy. And then we just compute a multiple sequence alignment with a substitution matrix that somehow reflects that singing bigger intervals in places you expect smaller intervals is complicated or like unexpected and you don't like to do it. And once we have an alignment, we can compute a phylogenetic tree, a phylogeny. We do this with a fully Bayesian model called Mr. Bayes, or Gustavo's modification thereof called Mr. Bayes Volpiano, that works with the Chant melody alphabet. And we apply this on a small controlled data set for Christmas Eve Vespers, the stuff that you would be singing on the evening of 24th instead of Christmas carols if you were a monk. We have some 14 sources, 6 chants from each, but importantly, they have a good spread across different institutions. So we have 3 sources from monasteries of the black monks, the Benedictines, 3 sources from the white monks, then we have an Augustinian, that was a mistake, but then and 7 sources from parish churches, from regular normal churches. And we would expect, based on what we know from music history, and this is what we validate the topology against, that the white monks' books are really similar to each other. The black monks' books are not so similar to each other because they didn't care as much about keeping their music consistent. And that probably geography should play some role, right? That books from a similar place should be more similar than books from different places. Does this work? Yes. The geographic gradient is there. It goes from France through the Low Countries, German-speaking countries to Bohemia. We have a lot of Bohemian sources. The black monks are all over the place, depending on where their monasteries actually were. The white monks have this very tight little group. So far, so good. But this is just some topology. This isn't really history. The tree is not ordered. This doesn't give us predictions about times and places and people. Okay, let's model time explicitly. We can do, oh, there's an error, divergence time estimation to decouple how much time has passed from one node of the tree to another from how quickly it changed during this time. We know the rough dates of origin for our sources, so we can compute this. It first requires selecting a root. This is normally done with an outgroup in biology, but we don't have an outgroup for Gregorian chant. But fortunately, we used a fully Bayesian phylogeny, so we can do model selection here. And fortunately, we can then also reconstruct the melodies themselves. This is just sampling over the positions on the nodes. And then we can make very specific music historical predictions. Fortunately, the model selection came out very unambiguously in favor of this particular edge. And if you project that onto the map, that's the river Rhine. So it's the other way around. So this stuff is west of the Rhine. This stuff is east of the Rhine. And lo and behold, there is a musicological prediction from 1925, or an observation, that Germanic sources tend to have slightly different melodies than Romanic sources. I mean, that guy didn't have a very nice history during the 1940s, so this work was mostly forgotten. But it's like the one thing that we have from musicology about chant dialects. Okay, we have the root. We can run divergence time estimation and get a time tree. So some explanation. This is time from left to right. It corresponds to that history of chant axis from the year roughly 800, where we have this root transmission event, all the way to the 1600s. We have the rate of change as the color of those edges. And the blue horizontal bars tell us something about the inferred distributions of the internal nodes in time. So they're positioned at their median age. Everything is a Bayesian, so everything's a distribution. They're positioned at their median age, and those are the, I think it's 95 percentile bars. We add the metadata for the sources. You can see how it very roughly corresponds to what we had here, right? The French parts up here, the Cistercians, which were over here, are up here. This is the Czech part, and these are the German sources and some more Czech sources. So very roughly, you can see the correspondence that is the same tree, but spread out in time according to what the model told us. So what music historical predictions are we making? Out of the many that I checked on this tree, I have time for one. I, of course, picked the most impressive one. So let's look at the common ancestor for the Cistercian sources, for the white monks. The median age predicted for their common ancestor is 1145. If you look into the history of the Cistercian order, you will find that Saint Bernard of Clairvaux was doing the standardization of the Cistercian antiphonary between the ages of 1140 and 1147. So like, I mean, this is the most impressive one, but there were more. I mean, we found a mistake in how one of the manuscripts was dated, for instance, based on checking against history. Another thing that comes out of this is that the East Frankish chant, the Germanic one, is probably slightly older than the West Frankish chant. This might have to do with a transmission through Ireland. This is one of the open hypotheses in chant scholarship. Did it all come from Rome with this Carolingian expansion, or was there another pathway, right, through Ireland? Because Ireland had monastic communities very, very early, before Charlemagne. I mean, it might break this assumption of a single root, but also it might not. There's a lot of musicological discussion around this in the 70s and 80s and even earlier. But we hope that maybe this is one of the questions that we can tackle. We can also reconstruct the melodies themselves. We just do position-wise maximum a posteriori estimation of which notes should be at a particular alignment position at a particular node. And again, we look to Wagner's ideas about what differentiates the East and West melodies. We find that while there are more places where our inferred ancestral melodies agree with Wagner's ideas, those are the green places, then places where they go the other way around, where like there's a French thing in a German source and vice versa. Those are the red parts. The vast majority of cases is that there is an opportunity for the sources or for their ancestral melodies to differ in the way described by Wagner, which is not taken. So they are the same, even though they could be different. So there is more to this East versus West Frankish chant melody than just the simplified descriptions of, okay, those guys prefer to sing ta-da-da, and the other ones present ta-da-da. It's more complicated. But I mean, that's what this is about. Of course, this was all done on a tiny, tiny validation data set. It was selected well, but it was just a small one. Currently, we are scaling this by one order of magnitude with experiments on about 600 mass introits. But of course, this is where optical music recognition comes in. And this is the potential, right, of OMR in computational musicology. You can do these experiments not on 600 introits, but 600,000. And of course, we want to try this melody reconstruction thing on those old sources that nobody is sure how to read. That would be pretty cool. I hope it works. Okay, that's it. I hope I convinced you that predicting music history is a thing and that it could be a thing at Matfis. Thanks.
Well, thank you very much for your talk. And now I would like to open the discussion.
Do you plan to cooperate with experts in the Gregorian chant, for instance, David Eben?
Certainly, yeah. I'm part of the DUCT network, which is a partnership grant that seeks to bring together computational people or computational musicologists with Chant scholars. Previously, I did some digital editions work with Hanna Vlhová-Werner. I talked to David Eben about this model a lot. He is my best sounding board because he's very skeptical. So I think I sort of convinced him that it starts to make sense, but yeah, we are definitely like taking this always to the Chant experts and back. Like, you cannot colonize musicology with computer science. It makes no sense. I wouldn't even know what questions to ask about Chant history without consulting with the musicologists.
Thank you. And the second question concerns Latin. Do you plan to cooperate with the experts in Latin? Because you need some knowledge of Latin in your work.
Well, fortunately, so far we're just working with the melodies. We're interested in how the melodic tradition evolved, not necessarily the textual one. And fortunately, what we need from people who can read the text is the catalog records to know which exact melodies are comparable to each other because they correspond to the same liturgical position. And we don't have to do this because the Cantus database and the Cantus index network of databases already has the catalogs. Of course, we talk to them. I mean, they're usually the same people who also know about Chant. But we don't need to talk to them as much because this work has already been mostly done. Understanding those red rubric texts, for instance, that's pretty complicated. So fortunately, we don't have to do it.
Thank you.
I like the idea, the good, bad, and ugly. But I'm not sure what Tom Hanks means on this slide.
No, it's just thanks.
I didn't get it.
Okay. So I think we just thank you for your presentation. I think our level of knowledge is really, really going up. And now I would like to ask the second contributor,